If you perform a quick search on how to secure your REST APIs in Spring Boot with JSON Web Tokens, you'll get a lot of the same results. These results contain a method that involves writing a custom filter chain and pulling in a third-party library to encode and decode JWTs. After staring at these tutorials, confused more than ever, I thought to myself, there has to be a better way to do this. So I did what anyone with access to the Spring Security team would do. I asked them. Sure enough, they informed me that Spring Security has built-in support for JWTs using Auth 2 Resource Server. In this tutorial, you're going to learn how to secure your REST APIs using JWTs and Spring Security. Welcome back, everyone. My name is Dan Vega, and I'm a Spring Developer Advocate for VMware. It's my mission to help you learn how to build and deploy applications through a series of tutorials like the one you're going to watch today. I'm really excited for you to go through this tutorial. It's been one of my most requested videos, and I spent a lot of time putting some thought into what someone would need to know to get up and running with securing REST APIs with JWTs. And I have built an article to go along with this video that has a little bit more in-depth walkthrough of things like the application architecture that we're going to go through that we just can't cover in this video. It's already like 45 minutes long. And so if you want a little bit more detail, I would suggest checking out this article. I'll leave a link to that in the description below. Again, this is really the starting line for securing your REST APIs with JWTs, not the finish line. I know there are more things that we can do, but I wanted to give you the bare minimum, the bare bones that would help you get up and running. So what I'd like from you is to go through the tutorial. If you have questions, please let me know. Leave them in the comments below. Reach out to me, and we'll see if we can't continue this journey of securing your REST APIs with JWTs in another video. With that, I hope you really enjoy this. Let's get right into it. We will begin our new project like we do every project over at start.spring.io. So we're going to fill in some metadata here. We're going to choose Maven, Java. We're going to use the latest stable release, which at the time of this recording is 2.7.3. We're going to fill in some metadata. So I'm going to say my group is dev.danvega. My artifact is going to be JWT demo. You can fill in whatever you want here. Packaging jar, Java, we're going to use Java 17. And next we need to go ahead and select our dependencies. So I'm going to be building out a web app, so I'm going to choose Spring Web. We also want to go ahead and bring in the Auth 2 resource server. And finally, we're going to use the configuration processor to create some configuration properties. So those are the only dependencies we're going to need. Now, I know you're probably thinking to yourself, Dan, where is Spring Security? And if you dive into the Auth 2 resource server dependency, you'll see that it actually includes a lot of the Spring Security stuff that we're going to need, and we'll take a look at that in a second. So right now, just go ahead and generate that project. I'm going to download that and open that up in my favorite IDE, IntelliJ. You can open it up in whatever IDE or text editor you're most comfortable using. I have the project open in IntelliJ, and the first thing I want to take a look at is if we open up that pom.xml, I just want to refer to something I talked about a minute ago, which is the Spring Boot Starter Auth 2 resource server dependency. If we dive into that, we're going to see a lot of the dependencies that we need for Spring Security. So we see Spring Security Config, Spring Security Core, we see the Auth 2 resource server, and also Spring Security Auth 2 Jose, which includes some of the stuff we'll use later, like the Nimbus Jwt Jwt library. So we have everything we need to get started. The first thing that we're going to need is a REST API that we want to go ahead and secure. I think for demo purposes, we're going to go ahead and keep it simple here. We'll just create a home controller in a controller package with a single method that returns a string. So what I want to do is go ahead and create a new package. We'll call this controller. I'm going to create a new class called home controller, and this is going to be a REST controller. And if we go ahead and create a get mapping, so this will be the root, we're going to create a method that is going to return a string called home. And for now, we'll just return hello JWT. Later on, we'll switch this to return the authenticated user's username. So with that in place, I can go ahead and run the application to make sure that it's working okay. And it does. If we go to localhost 8080, it will now redirect us to a login page because everything is secure by default. That's Spring Security takes that kind of secure by default approach, which means that everything is locked down. And you are going to have to open things up as you wish, as opposed to kind of leaving everything open and then you having to lock things down. So that is kind of the start of it. So by default, Spring Security is going to set up a default user named user with a password that is generated for you here in the console. But it is our job that at some point, the default security configuration is not going to be enough to get us up and running, right? It's good for demo purposes, but at some point, we're going to need to provide our own configuration to fit the needs of our application. So in the past, you would have to extend something called the Web Security Configure Adapter. This has since been deprecated in Spring Security 5.7. If you're interested in learning more about that, I have a video on that. I will go ahead and link to in the description below and in the card up above. So if you want to go ahead and pause this one and watch that one to kind of get up to date on the security changes, go ahead and do that. What I'm going to do, though, is I'm going to create a new package here. We're going to call this config. This is where all my configuration classes are going to go. I'm going to create a new class, and we're going to call it security config. Again, this is really up to you. We're going to go ahead and annotate this with @configuration because we're going to define some beans in here. And we're also going to enable web security. So the first thing we're going to create in here is a bean of type security filter chain. We'll call this security filter chain. This actually takes in HTTP security. We'll call it HTTP. And at the end of the day, what we want to do is we want to return http.build. And that is what we will return. And this will throw an exception. And so here's where we get to really start to customize our HTTP security. So the first thing I'm going to do is disable CSRF, cross-site request forgery. So CSRF, we'll go ahead and say CSRF.disable. And then we're going to set up our authorized requests. So this is going to say, what do we want to do here? By default, I just want to say any request, I want you to go ahead and be authenticated. That is going to be kind of the default for us going forward. Again, because we've, by default, Spring Security or Spring Boot did that. It kind of locked everything down, right? But we have overridden the default security. So now we have got to be responsible for anything that we're doing here. So we want to say, go ahead and authenticate anything. So the other thing we're going to do is we're going to turn off session management. We're going to create like a stateless session because we are just kind of using REST APIs here. We don't need a session. So I'm going to say session create policy. We want stateless, and that is that. Finally, I need a way to authenticate users. You could use like a form login like the default security configuration had. We're going to use HTTP basic here. Again, it's easy to get up and running, and for this purpose, it's great. So I'm going to say customizer.with defaults, and I'm going to actually import that as a static import. So we just have with defaults and build. So that is looking good. Let me go ahead and shorten that a little. So far so good, right? Just a quick tip. Never disable CSRF protection while leaving session management enabled. Doing so will open you up to a CSRF attack. So just an important note there, not in this app, but in any of your other apps. So now that we have our custom security in place, you need a user that isn't that default one, right? I want to go ahead and create a new user for this system. And to do so, I'm going to create a new bean. We're going to say public in-memory user details manager. We'll call it user. And we're going to return an in-memory user details manager. And in here, we'll go ahead and create a new user with username dvega dot password. So I need to encode this password. I could create it like a no-op password encoder bean, but you can also do that right here in the password just by saying no-op and password. And then I also want to set authorities, which we won't really get into in this particular tutorial, but could be useful later down the line. And we'll go ahead and build that. And I probably missed something. User, oh, we need a new. That would help. All right, so that will give us a default user in the system. With that, we should be able to go ahead and save that, restart, stop and rerun. And we see that in the console, we no longer get that generated password for the default user. So now if I go over to localhost 8080, we go ahead and we get JWT. I wonder if it's picking up a prior, let's just see. So yeah, it must have been picking up a prior login. So if I just type in anything, it's not going to let us. But if I go ahead and use dvega and password, all right, we are able to authenticate and we are able to see our JWT, hello JWT. So with that in place, I'm just going to change one little small thing. At some point, we want to display the authenticated user's username. So I'm going to go ahead and say principal.getName. Let's go ahead and restart this and rerun this. And there is our username. I just want to take a quick break to say this is a good time to head back over to the article and dive into the section about OAuth 2 resource server. So in there, we mentioned that, hey, there's Spring Security supports protecting endpoints using two forms of OAuth 2 bearer tokens, and that's JWT and opaque tokens. So again, we're jumping into JWTs. This is really handy when you want to delegate authority management to some type of authorization server. So now we've introduced a couple terms here, right? Resource server and authorization server. Normally in a larger scale distributed application, you would have an authorization server that handles this, and that's a separate service. Today, we are using self-signed JWTs, and this will eliminate the need to introduce an authorization server. So we don't need that today. This works for this example, but as your application requirements might be different or as they grow, the question that's going to come up is, when is this no longer acceptable? When do I need to move away from self-signed JWTs? And I got two really good answers from the Spring Security team, and this was just really quick, so I'm sure they have better in-depth answers, but I thought they were really concise and right to the point. And so I want to share those with you. Again, these are in the article. When you reach the point where the trade-offs for self-signed JWTs are no longer acceptable, an example might be the moment you want to introduce refresh tokens. So if you need refresh tokens in your application, maybe you need to move to an authorization server for that. The other one was I'd add that a distinct authorization server makes more sense when you have more than one service, or you want to be able to harden security, isolating something as critical as authentication provides value because the attack surface is reduced. And I thought those were really great answers. In a distributed architecture, you wouldn't want to recreate the authorization mechanism multiple times, right? So you can just have one authorization server. And we're going to be doing more tutorials on this. Spring Authorization Server is coming up on 1.0 milestone. So we'll start talking about that more. If you have questions about that, please let me know. I've given you some resources in the article to talk about resource server for the documentation. Hey, what does resource server with JWTs mean? And hey, what is this Spring Authorization Server? I do need to move to something like that. What is it? How can it help me? So I just wanted to take a quick break to talk about what a resource server is, what an authorization server is, because these are terms that you're going to be hearing. But with that, let's jump back into the tutorial and start writing some code. All right, now that you know what a resource server is and what it's used for, we need to configure one. So you can do this right in the security config by setting the OAuth 2 resource server option here. So we're going to say OAuth Oauth2 resource server. And then what we need to do is pass in a configurer. So we could create our own, but luckily for us, we don't have to. There is a class called the Oauth2 resource server configurer. So Oauth2 resource configurer. So if we jump into this, we can take a look at what this is. So this is an abstract configurer used by the resource server. By default, this wires in a bearer token authentication filter, which we'll need, which can be used to parse a request for bearer tokens and make an authentication attempt. So we have some options here of what we can configure. What we want to use is the Jwt Customizer. So this enables Jwt encoded bearer token support. So that's what we're looking for. So we can do that with a method reference here and just say JWT. So that is going to give us exactly what we want. Now I want to look at this class one more time, because if you look up here, if we use the Jwt Customizer, we need to do one of the following. We need to either supply a Jwk set URI, a Jwt decoder instance via this, or we need to expose a Jwt decoder bean. And the reason is, if you go ahead and restart this, we are going to get an error. And it is saying, hey, in that set filter chains, we need something called a Jwt decoder, and you have not defined one. So that is what we need to do next. All right, so we need to talk about signing JSON Web Tokens, and to do so, I'm going to go back to the article that I've written to accompany this tutorial. So we know we need to create a Jwt decoder, but there's some things that we need to do here. As we learned earlier, there are three parts to a JWT: the header, the payload, and the signature. That signature is created by encrypting the header and payload, or encoding the header and payload with a secret, or by signing it with a private key. So the definitions are here on screen. You can pause the video if you want, but you can either use a symmetric key, which is a shared secret, so just like a secret key, or asymmetric keys, which is the use of a private key of, a private and public pair. So that's symmetric versus asymmetric. There are pros and cons to each, but it's generally recommended that you use asymmetric keys. So that's the approach that we're going to take here. So what we need to do is we need to create a public-private key pair. This is something you can do via code, and it might make sense to do it. But for now, we're just going to create them manually, statically here. And I think it'll just kind of give you a window into what we're doing. So I'm going to create these in a new folder under source main resources, and we're going to create a new folder here called certs. Again, you can really call it whatever you want. So I'm going to call it certs. And so what I need to do is actually open up a terminal to that location. So I'm going to go into source main resources certs. And now that we're there, let's go ahead and make this a little bigger and clear that up. So we are going to run a few commands. Again, we're going to use something called OpenSSL, which is installed by default on macOS. You should be able to get it on whatever operating system you're running. Normally, I think we can get away with 2 commands, but I'll talk through the reason for the 3 commands here. I'm not an OpenSSL expert. I'm not a RSA token expert. So if somebody wants to call me out on that in the comments, please do so, and we'll get that fixed up in the article. But what I do here is I'm going to run OpenSSL, and what we want to do is we're generating an RSA token or an RSA key. So we're going to say RSA, gen RSA. The out is going to be named keypair.pem, and then you're going to use the kind of encryption level. I'm just going to say 2048. This is kind of the min standard. You can use all the way up to, there's different options for that. So I'm going to go ahead and do that, and we see we generated an RSA private key. So this is generating the private key. I know I called it key pair, but I'll tell you why in a second. So from the private key, we can extract a public key. So the way that we do that is we say OpenSSL, RSA, and then the in is going to be the keypair.pem that we just created. And what we want to do is we want to get a public out, And the out file is going to be called public.pem. So if we run everything okay, we missed something here. Let's see. RSA, not RS. Let's fix that. Writing RSA key. So now if we look in here, we have a public key. This is a public key. Now, if we were to just call this private and run with it, at the end of the day, we would end up getting an error in our application saying that the private key needs to be in a PM encoded PKCS8 format. So what I'm going to do is make sure that we have a private key in that format. To do so, I'm going to run OpenSSL PKCS8 top K8 inform. So inform PEM. So out form is going to be PEM. No crypt in, and then the in file is going to be the key pair.pem, and the out is going to be private.pem. So if everything works, we should have a private. So we have a private key, and now we have a public key, and those are in the formats that we need. At the end of the day, if everything worked, you can get rid of this. All we really need is the public and the private key. All right, so we have our public and private key. What I want to do now is create some configuration so that we can configure where the private and public key are coming from. We want to externalize this, so eventually, if this were to go to production, that private key that we have in our search folder is not something we would want to commit to Git, right? This is something we'd want to store privately. We can externalize that configuration and then load it maybe from like an environment variable in some other environment. So to do so, that is why at the beginning of this tutorial, we brought in the Spring Boot configuration processor. What we're going to do is create in our config package a new record. So we're going to say Java class. This is going to be RSA key properties, and it's going to be of type record. We're going to mark this with add configuration properties. We'll have a prefix of RSA, and that is that. So this is the hide notification. We know that we need to go ahead and say, let's just do prefix. And then to make this happen, I'm going to go over to here and say enable configuration properties, RSA key properties.class. That should be that, and that is that. So this is really just going to take in two arguments here. So they're going to both be, or actually they're going to be different types. So we're going to have RSA public key, and this is going to be public key, and then RSA private key. This is going to be private key. So that's all we need to do for this class. Now what we can do is go ahead and set those values. So I'm going to come over to application.properties. I'm going to say RSA. Now again, they're not going to be available yet. And this is just something I've covered in other videos. But once we made that change, we added that configuration properties, we do need to run this build. And then you'll see them show up down in our target folder. And now as we start to type, we will get that IntelliSense. So I'm going to say RSA private key. This is going to be a so class path, and this is going to be inserts and private.pem. RSA.public key is class path inserts.public.pem. Okay, so that looks pretty good. Now what we can do is we can go back to our security config, and we can refocus back on the JWT decoder. So remember I said one of those things that we have to do is we can define a JWT decoder bean. And the way that we do that is we just say app bean here in our Spring security config. And this is going to be of type JWT Decoder. JWT Decoder. And we need to return some type of JWT decoder. So back when we took a look at some of the dependencies that the Oauth 2 resource server brought in, one of those was the Nimbus Jwt or Nimbus Jwt Jose, I think it is, or Spring Security Auth 2 Jose, which brings in Nimbus Jose to JWT. At the end of the day, we get something called a Nimbus Jwt Decoder. And this class has a bunch of useful methods in here, and one of which is with public key. So we know that, again, there are two different ways. We can have symmetric or asymmetric. If you're using symmetric and you're just using a secret key, you could use with secret key. We are using that public-private key, so we're saying with a public key, I want you to go ahead and decode that. So now we need to find out where that public key is, right? And the way that we can do that is we can get a reference to that RSA key properties class that we have. So we could say private final RSA key properties, RSA key, let's just say RSA keys, keep it simple, and we'll get that through a constructor injection. So now down here, I can say RSA keys dot public key. And we want to go ahead and build that, and that will return a JWT decoder. So remember, we started the application up earlier without this being, and we got that error. What I want to make sure now is that if we've done everything right, we can start up the application and there is no error. So that's telling me two things. We've correctly configured this JWT decoder bean, and we've also have the correct path set in application.properties to those files, or we would get something thrown there as well. You have the keys in place and you've defined a decoder, which is a way to decipher that JWT. If you remember back to our architecture diagrams earlier in the article, the user will need to log in with their username and password. So we're using basic authentication here. And if they pass authentication, we need to generate a new JSON Web Token and send it back in the response. So to make this happen, the first thing that we're going to do is back in our security config, we're going to create a bean of type JWT encoder. So we have the decoder, we need an encoder. So let's go ahead and say bean JWT encoder, JWT encoder, and what this is going to return is a new. So again, we use Nimbus for the decoder. Nimbus is the libraries here. We have a Nimbus JWT encoder. What this is going to take is a Jwk source. So we need a way of creating that. So we're going to start off with creating Jwk is equal to new RSA key dot builder. And this is going to take in our public keys first. So we're going to say RSA keys dot public key. And we're also going to pass in our private key. And we're going to go ahead and build that. So once we have the JWK, we can create a Jwk source. This is security context. And we'll call this JWKS. And we're going to use the immutable Jwk set, which is going to take a Jwk set, and we can just pass in that Jwk we defined above. So with JWKS, we can pass this in as an argument, and that should give us everything we need to create an encoder. So we could create a controller now, and we can use this encoder directly in say, our authentication controller. But I feel like this is something that we should extract out to a service layer. So what I want to do here is I'm going to create a new package here. We're going to call this service. And in here, I'm going to create a new class, and we're going to call this token service. And in token service is going to be of type service. Again, if you're new around here, this could be at component. This is a specialized annotation of component, but this will just tell Spring, hey, this is a class that I need you to go ahead and manage for me, create it, stick it in the application context so I can use it later. So Now that I have this token service, I need that JWT encoder. So I'm going to say private final JWT encoder. Here's our encoder. We'll go ahead and get that through constructor injection. Now I need a way to generate the token. I'm going to go ahead and just throw some code in here and we'll talk about it. Let's import the security one. And let's see, why is this not, why did we not call this encoder? That would have been better. Let's just do that and that. Okay, so this generate token method is going to take in authentication. So this will be our authenticated user. It's going to create an instant for now. Get a timestamp, basically. It needs to create a scope. So the scope is a string. So it streams over the authorities, maps them to a granted authority, and just creates a string based off of those. And then this is the important part, the Jwt Claim Set. So this is, we're saying the issuer is self. Remember, we're self-signing these JWTs. When was it issued at? When does it expire? I'm saying now plus 1 chrono unit of hours. So this will expire in an hour. If you want to go ahead and change that unit to be whatever to fit your needs, please do that. The subject is the authentication. That's the principal.getName. The claim is the scope, and then we pass in the scope that we created up here, and then we go ahead and build that JWT claim set. Then we can use the encoder to encode that. So we're calling the encode method from the encoder and using the JWT encoder parameters from our claims, and then we get that token value. So that at the end of the day returns a string, that generated token that we need. So now that we have that, now we can kind of start to fill this in, kind of one of the last pieces here, which is we need a controller. We're going to call this Auth Controller. And this is going to be a REST controller. And so the first thing I'm going to do is I'm going to get a logger in here so I can go ahead. Why didn't I change my live template to do that? And what I also need is a token service that we just created. So token service. And we will go ahead and get that through constructor injection. And what I'm going to do is create a method called token, which is going to return some kind of string. So this is going to be a post mapping, not a post construct. And we're going to map this to /token. So this is the endpoint that they're going to hit. They need to pass in some type of authentication. We know that's going to be basic auth because that's what we set up. And what I want to do is just go ahead and do some logging in here. So I'm going to say log debug token requested for user. And we'll say that placeholder. And then we'll say authentication.getName. Did we pull in the wrong authentication? I keep doing this. Yes, we did not want that one. We wanted the Spring Security Core, and we can get name from that. So we want to get the token now. So we're going to say string token is equal to our token service.generate token. We're going to pass in our authentication, and that should give us what we need. So I'm just debugging this for, development purposes so I can see who requested one, what the token was generated. So I'm going to say token granted, and we'll just go ahead and pass in the token there. So at the end of the day, we're going to actually return that token. And if everything was done correctly, we should be able to restart our application without any errors. Oh, and we did it. The demo gods are smiling upon us today, my friends. So everything should be working, right? But we need a way to verify that it's working. All right, so there are a couple ways that we could manually test this, but in this tutorial, I just want to show you two quick ones. The first one and the easiest way is to probably use a tool like Postman. So if we head over to Postman, we can create a GET request to localhost 8080. Again, everything's locked down right now. So if we go ahead and send this request, we are going to get a 401 unauthorized. We need to log in first. We are not authenticated to view this localhost 8080. So what we can do is we can send a post request to localhost 8080/token. Again, that is what we created here. So /token. This will take in some authentication, pass it to our generate token method, and then create a token. This is just realized there's a typo here. So this should give us everything we need. Let me just restart that. Okay, so far so good. So let's go over here and go to localhost 8080/token. And now we need to pass in our user credentials. So the way that we do that here in Postman is through authorization, and we are using basic auth. So I'm going to pass in our Vega and password. And if I go ahead and send this, here is that JWT token. Now what we can do with this is take this over to this other request, localhost 8080, and in the authorization tab, we can pass different types of auth here. One is a bearer token. And so this is that token that we got back. It's called a bearer token, and we pass it along with the request. Now if we make this request, we go ahead and we hit the endpoint, we get a 200 OK. It says hello, and if you remember, we added the authenticated user in as an argument, so we're able to get the authenticated user's username there. So that's one way to do it using Postman. Another way that we can do it is by popping open a terminal here. So I'm going to clear this out. And I have a little application that I love called HTTP, and it just makes running commands from the command line, especially testing out APIs, makes it a little bit easier. So what I can do is I can say HTTP post. So I'm running a post request to /8080 and /token. And I'm passing in some auth, which is Vega and password. And if I use the -v argument, I get to see both the request, so the request sent, and you can see we're sending an authorization, HTTP basic, and here is the base64 encoded username : password. So what we get back is success. So we get this token back, right? So now we need a way to go ahead and pass that to localhost 8080. And we can do that. So we can just say HTTP, let's come back, HTTP 8080, and I'm passing in the authorization header. So the way that this works is it has a bearer, the keyword bearer, and then the JWT token. And we want to go ahead and close that there. And if you see that, it ran successfully. So 2 easy ways to go ahead and manually test it using both Postman and going ahead from the command line. Now, again, I'm using a program called HTTP. You can do this with curl as well. Well, it's just a little more verbose, and I never remember the commands to do that stuff. So that's why I use that program. All right, so manual testing is great, but you can see everything is working as it's intended. However, we're going to need some automated tests in place so that as you make changes, you can be confident that what you're introducing is not breaking existing functionality. So I'm not going to go into this too much. This tutorial has gotten pretty long as it is, but I just want to provide you with a simple example of how to write such tests. Before we can do so, you have to go into the pom.xml, and we can see down here we have this Spring Boot starter test. When we brought in that OAuth 2 resource server, one thing that didn't get brought in was the Spring Security test library that we need. So I'm going to say Spring Security test, and that's from Spring Security. So let's go ahead and reload our changes, and everything is okay. I'm going to close that. I'm going to go into my home controller, and I'm going to create a test called home controller test. And let's just go ahead and make this easy and put in some code here. So we are doing a couple things. We're going to have to bring in all of these. I'll just do these as we go. So we are creating a slice test, and we are specifically focused in on the home controller and the auth test. Because of that, we're doing a slice test. We're not going to load everything into the application context. We need to import things that we're going to use, like the Spring Security config and the token service. Because it's a slice test, we get a auto-wired instance of our mock MVC. And then the test is, hey, when it's the root, when it's unauthorized, then, hey, we should get a 401. MVC, let me just go ahead and add these in so we don't have to go through and add all of these. Is that not in right? And that one. Okay, now we should be okay. So that is that one. Then we have a root when authenticated, then says hello user. So I'm actually just showing you two approaches to this. One, we're going to make a post to token with our HTTP basic username and password. That should be okay, and it should return something. From that result, we're going to actually get the response so we can get the token, then make a request to our root with the authorization header, with that bearer token, and we expect what we get back should say hello, and then my username is dvega. Also, just a simple test here, you can use this @with mock user annotation. So now what we're saying is, hey, we just want to make sure that we get a 200 back and that we're not getting a 401 back. So let's go ahead and run this. And great, all tests passed. Now we have our automated tests in place. Now in a real world application, there would be more tests here, right? But I just wanted to show an example of how you might test this out because we do want these automated tests in place. Again, it just kind of gives us the confidence as we're making changes that we're not introducing any new bugs. I really hope you enjoyed that tutorial. When I sat down, I had really created a goal for myself to create a tutorial through article, through a video, to let everyone know that there was an easier way to secure your REST APIs with JWTs, and that Spring Security has this support built in. So I hope I've accomplished that goal. I did for me. Again, that was one of my passions here is learning and then teaching that to you guys. This is something I needed to learn too. So it was fun kind of going down this rabbit hole and understanding what Spring Security has to offer out of the box. So I hope you had some fun learning with me. Also, I said this in an article, but I feel very fortunate to work for a company like VMware, to have access to the resources that I have access to, which is teams like the Spring Security team. They were all very helpful, not only extremely smart, but everybody's just very open to sharing knowledge. And now I know you don't have access to every single engineer at VMware, but you do have access to me. So if you have questions the way that I have questions, please reach out to me. Let me know what they are, and I'll see if I can go ahead and help you out. So as always, friends, if you found value in this, please give me that thumbs up. That really helps me out. Subscribe to the channel. And as always, happy coding.